Everyone, for today's lesson, we are going to learn how to add and subtract rational expressions. Before we get started with this lesson, I would like you guys to please complete this very quick warm-up where I would like you to please add without a calculator 2/5 plus 1/2 and 2/3 plus 1/9 and 3/5 plus 2/5. Show whatever work you need to show. And then when you have an answer, please go ahead and restart the video and we will see how well you did. All right, so if you can handle adding problems like these, you can handle today's lesson. This lesson is all about adding and subtracting rational expressions, which is founded in the process of adding and subtracting regular fractions, something that we learned about a long time ago when we were in elementary and middle school. So in this problem, we have 2/5 plus 1/2, and hopefully you found that the least common denominator between 2 and 5 is 10. And the way that you turn each of these denominators into a 10 is you multiply each fraction by the number 1 in a different form of what you need. So for example, we need to multiply 5 times the number 2 in order to make it a 10. But we know that we don't want to change the value of the fraction. We just want to change the look of it. So we're going to multiply both the numerator and the denominator by 2 because technically we're just multiplying this fraction by the number 1, changing its look and not its value. So now we end up with 4/10, which is equivalent to 2/5. In order to change 2 into the number 10, we multiply the denominator by 5, but whatever you do to the denominator, you have to do to the numerator. We're going to change this number of 1/2 into 5/10. We're not changing the value of this fraction, we're just changing the look of it. So that we now have ourselves like things. We're going to be adding tenths. 4/10 plus 5/10 equals 9/10. And hopefully you got 9/10 as your answer and showed very similar work on your paper. Let's look at number 2. For problem number 2, I have 2/3 plus 1/9. Well, the common denominator between 3 and 9 is 9. 9 can go into itself, and if I simply multiply 3 times 3, I will get a 9. And whenever I do to the bottom, I will have to do to the top. So 2 times 3 is 6. So this is simply 6/9, which simplifies to 2/3. So 6/9 plus 1/9, which is 7/9. And now we're going to look at number 3, which is the easiest of all of them. There we already have a common denominator. And if we have a common denominator, we simply add our numerators. We'll end up with 5/5. And we all know that 5/5 is 1. And if it's possible for you to simplify, the expectation is that you always do. So this skill of adding fractions, like I said before, is the foundation for our lesson for today. Our learning targets are for you to be able to say, I can identify the least common denominator, also known as LCD. Look at that. We worked with LCD in all of our examples. I can identify the least common denominator by identifying the least common multiple, which is called the LCM, of the denominators. And I can add and subtract rational expressions with like and unlike denominators. Now, the procedure used to add or subtract two rational expressions depends upon whether the expressions have like or unlike denominators. So we're going to start this lesson off with like denominators because those are the easier ones. To add or subtract rational expressions with like denominators, we simply need to add or subtract their numerators together because they already have like denominators. Then we'll place the result over the common denominator, and if we have to simplify, we will. So in our example that we have A over C plus B over C. We have a common denominator, so we add our numerators, A plus B over C. If it is possible to simplify, make sure you do so. The same exact steps are true for subtraction. So in this example, we have a common denominator of 5x squared. We're going to simply add our numerators. This is 3x plus 7 over 5x squared. In this example, we're going to subtract our numerators because our denominators are the same. So I have 9x cubed minus x squared. This is all over x plus 1. And just like we talked about in our last couple of lessons, we want to always make sure our final answer is in factored form. We always leave it in factored form, the numerator as well as the denominator. So in this problem, the two terms in the numerator both have in common an x squared, with our leftovers being a 9x minus 1. This is all over x plus 1. The nice thing about factored form is that it gives you an idea of what can be canceled and what can't be canceled. Remember that in order to cancel, the main operation in both the numerator and the denominator have to be multiplication in order for you to be allowed to do that. Let's go ahead and look at example number 1. In example number 1, we have 7 over 12x minus 2 over 12x. We have a common denominator of 12x, so we're going to subtract 7 minus 2, which is 5. There's our answer. Let's look at letter B. For letter B, we have a common denominator of x squared plus 1. Let's go ahead and combine our numerators. We will end up with 2x squared plus 2 all over x squared plus 1. 2x squared and 2 both have in common a 2, so I'm going to factor out a 2, leaving me with x squared plus 1 all over x squared plus 1. Now remember, if you see something that's the same, technically the main operation in the denominator is multiplication if you change that to a 1 times x squared plus 1. So therefore, we know that the x squareds plus 1 are going to cancel away, leaving us with 2 over 1, which is 2. When we come back together, we're going to discuss the solo questions, but I'm going to talk about this solo question with the star next to it. Whenever you subtract, we want to always make sure that we're subtracting the entire numerator. So you're going to want to make sure that you are careful with your and make sure that you put parentheses just to make sure that you are distributing that negative symbol to every single term. All right, let's go ahead and move on to the next page. So working with common denominators is pretty easy, but working with unlike denominators is a bit more challenging, especially once we start working with polynomials. So to try to help you with that, we're going to practice the idea of identifying a least common multiple using polynomials, because that skill of finding a least common multiple is similar to the skill of finding the least common denominator of two or more fractions. Now, in order to find a least common multiple, here are my rules, and they're in layman's terms. Every factor must be represented once, only once. And if there is a repeat, then whatever has the highest degree automatically wins and will be part of your least common multiple. So pretend as if all of these expressions are denominators. Let's say this was like 1/3 and 1/3. Our common denominator would be a 3. That's your least common multiple. Let's say your denominator was an x and an x. Just like with the 3 and the 3, least common multiple is the letter x. And if your denominator was an x plus 2 and an x plus 2, your common denominator would be an x plus 2. But what if your denominator was a 3 and a 9, just like our warm-up? Remember that we always go with the bigger number, and I know that I can multiply this 3 by another 3 and it will equal 9. Another way you can view this is that 9 is really 3 squared. So since these two numbers are the same, I always said highest degree wins. So therefore 3 squared, which is 9, is going to be my least common multiple. Same thing goes with x plus 2 compared to x plus 2 squared. Highest degree will win. So therefore, x plus 2 squared is going to be my least common multiple. What if your denominators were 3 and 2? What would the common denominator be between 3 and 2? Well, we want to look for least common denominator. In this case, it's going to be 6. When two factors have absolutely nothing in common, sometimes or most of the time, their least common denominator is going to be their product, 3 times 2 being 6. You could also work with 12 and 18, etc. But we are looking for least, and 6 is going to be that value in this case. Between x and x squared is going to win. So they both have an x, but remember, highest degree is going to win. X squared is going to be my least common multiple. Now letter H. We're getting into something that's a little bit different. So I have a 6 times x plus 1 squared, and I have a 4 times x plus 1 times x minus 1. So my recommendation when it comes to problems like these is to always work with numbers first, and then work with the expressions. So if I were just to focus on the fact that I have a 6 and I have a 4, what is the least common denominator between 6 and 4? That is going to be a 12. That is the smallest number that both 6 and 4 are factors of. Although 24 works, it's not the best approach. So I'm going to put a 12 right here. Now, they both have in common an x plus 1, but this one has an x plus 1 squared. So I'm going to write x plus 1 squared. Now remember, every factor must be represented once. And so I've already dealt with the numbers. I've already dealt with the x plus 1. X minus 1 needs to be represented. So x minus 1 is going to be part of my least common multiple. Letter I takes it to the next level. We now need to factor. And so I'm going to bring out a 5 from 5x squared minus 45, and I'm left over with an x squared minus 9. We all know that x squared minus 9 is a dot, a difference of 2 squares. And so we need to factor completely, and this will help us to identify what our factors are. So I have 5x plus 3 times 5x minus 3. 4x squared, 24x, and 36 all have in common a 4, with our leftovers being x squared plus 6x plus 9. And we all know that x squared plus 6x plus 9 is a perfect square trinomial. So I have allowed you guys to rewrite this as x plus 3 times x plus 3, but now that we really are interested in the degrees, I really need you to write this as x plus 3 squared, and this will help you with your analysis of trying to figure out what your least common multiple is. So just like we did in the last example, we're going to work with our numbers, and the smallest number that both 5 and 4 are factors of is 20. So that's our least common multiple between 5 and 4. Next, I'm going to work with the x plus 3s. This one has an x plus 3. This one has an x plus 3 squared. So the x plus 3 squared wins, highest degree wins. And then we need to make sure that we have x minus 3 represented. So every factor must be represented once. If there is a repeat, the highest degree will win. Let's look at letter J and letter K. For letter J, we have 5x cubed and 10x squared minus 15x. So for 5x cubed, there's nothing really to simplify here, but 10x squared and 15x both have in common a 5x, with the leftovers being a 2x minus 3. So between 5 and 5, your least common multiple is 5. Between x cubed and x cubed wins. It's the highest degree. And then we need 2x minus 3 to be represented as well. So there is your least common multiple. And finally, between 8x and 16, they both have in common an 8. So we have 8 times x minus 2. And then 12x squared plus 12x minus 72 are all divisible by 12. Leftovers is x squared plus x minus 6. And then I'm going to factor this more by turning this into an x plus 3 and an x minus 2. So we want to look for the smallest number that both 8 and 12 are factors of. And if I were to think about 8, I know that it goes 8, 16, 24, 32. And 12 is 12, 24, 36. So 24 is the smallest number that both 8 and 24 can go into. I see that we have an x minus 2 and an x minus 2. Since it's a repeat and the highest degree wins, the highest degree is a 1. So an x minus 2 is being represented once. And then I need an x plus 3 to be represented. So this is how you identify a least common multiple. Remember those two rules. Always rewrite these expressions in factored form. Every factor needs to be represented once with the highest, if there's a repeat, the highest degree wins. Please note that you will use this skill of finding a least common multiple to help you add or subtract rational expressions that do not have a common denominator. So this next step or this next page is all about comparing the language of an LCM versus an LCD. Please note that the smallest common multiple of two or more numbers or expressions is called the least common multiple. So the smallest common multiple of two or more numbers or expressions is called the least common multiple, also shorthand LCM. The least common multiple of two or more denominators, so the LCM, the least common multiple of two or more denominators, is referred to as the least common denominator. So a lot of kids get that language all mixed up. So that's the point of this section, is to try to make sure that that I emphasize the difference. The skill of finding a least common multiple will be used. That same process will be used to find an LCD of two fractions, as we did to find the LCM of two expressions. So please note that these ideas are related. I'm going to talk to you guys about something that's important. Just in case you ever get stuck in a process, please note that you can always find a common denominator. Doesn't necessarily have the word least in there, but you can always find a common denominator of two rational expressions by simply multiplying their denominators together. However, if you use the least common denominator, which is the least common multiple of the denominators, then you will have less simplifying to do. And we are all about doing less work in mathematics. So I really do want you guys to work with that least common denominator. Here's the reason why. Looking at this first example, let's say that we were working with the least common denominator. So looking at 1/6 plus 1/4, we know that the least common denominator is 12. So I'm going to change both of these denominators to 12. I would multiply this first fraction by 2/2 and the second fraction by 3/3. 2 times 1 is 2, so 2/12 plus 3/12 will give us 5/12. Not a whole bunch of work to show. But what another approach is that you can work with 6 times 4, which is 24. You could just multiply this fraction by 4/4 and this fraction by 6/6. You'll end up with 4/24 plus 6/24, which is 10/24. But we have to simplify that 10/24 even further. Dividing both the numerator and the denominator by 2, we end up with 5/12. So you can still end up with that same answer of 5/12. It's just one's going to cause you to have more simplifying in an extra step. And although it's really not that big of a deal when you're working with numbers, it can become a big deal when you're working with polynomial expressions. So you want to be really careful and really go out of your way to work with that least common denominator. So adding and subtracting with unlike denominators is our next section. And to add or subtract rational expressions with unlike denominators, you're going to need to find a common denominator, preferably the least common denominator. Then you'll rewrite each expression using that common denominator and then add or subtract. So let's go ahead and hop right into our first example. And this is the steps that I would like you guys to show. So we have 3/4x minus 1/7. And what I'm going to do is I'm going to write LCD at the top. You always want to identify what your LCD is going to be using the exact same steps that we had on the last page. So let's pretend that we're just working with 4x and 7. Working with our numbers, what number is 4 and 7 both factors of? That's the smallest. Well, 4 and 7 have nothing in common, so maybe their product will work. 4 times 7 is 28. And then we need to have that x represented. So 28x is our least common denominator. And that's what we want to change both of these denominators into, 28x. So I need to multiply this first fraction by a 7 over 7 because I know that 4 times 7 is 28. 7 times 3 is 21. And if I were to simplify this fraction, it would still bring me back to 3 over 4x. I need to multiply the second fraction, the 7, by what it needs. 7 times 4x will give me 28x. And whatever you do to the denominator, you have to do to the numerator. And so therefore, I'm going to multiply 1 times 4x to get 4x. And my answer is now going to be 21 minus 4x all over 28x. You're also welcome to rewrite this as negative 4x plus 21 over 28x if you want to do that as well. It doesn't matter. Either answer is perfectly correct. If you could simplify, the expectation is that you would, but we always leave our denominators in factored form if necessary. Let's go ahead and look at example number 4. In example number 4, the first thing we want to do is identify a least common denominator. And looking at 3x squared and 9x squared minus 12x, I'm going to make sure that I factor my denominator first before making any decisions. So I know that 9x squared and 12x both have in common a 3x, with the leftovers being 3x minus 4. So I know, looking at my numbers, 3 and 3, least common denominator better have a 3 in it. Between x squared and x, I need it to have an x squared, and then I need the 3x minus 4 to be represented as well. So I need both of my denominators to be 3x squared times 3x minus 4. And now I'm going to multiply each fraction by what it needs. So this first fraction already has the 3x squared, and what it needs is it needs the 3x minus 4. So I'm going to multiply both the numerator and the denominator by 3x minus 4, and I'm going to make sure I put it into parentheses. Even though it works out in this case because it's a 1, sometimes this becomes like an x plus 1, so you might have to FOIL or use the distributive property. So that's going to turn this into 3x minus 4. The next fraction already has a 3 and an x, as well as the 3x minus 4, but it doesn't have an x squared, so it needs an additional x. So I'm going to multiply both the numerator and the denominator by x. X times x is x squared, and if I multiply by x, I'll end up with my common denominator. So now I'm going to combine my numerators, and I'm going to put that x squared first, so it's in standard form, of x squared plus 3x minus 4 all over 3x squared times 3x minus 4. Always make sure you leave your final answer in factored form, and I'm going to try to factor this numerator. Splitting apart the x squared into an x and an x, I have to ask myself what two numbers multiply together to equal negative 4 and together add to equal positive 3, and that's a plus 4 and a minus 1. This is all over 3x squared times 3x minus 4. This is our final answer. If there was more to simplify, the expectation is that you do so, but if you can't, then you don't. The next two examples are pair questions, and so I'm going to let you guys do those the next time I see you guys in class. Please try them on your own if you would like. That might be helpful. But this is the end of this lesson. If you guys have any questions over anything I showed you, please feel free to email me. Otherwise, I hope you have a wonderful day.